No comment, Erica. No comment. Plead the fifth. All right, so we're not going to quite get into completing the square right yet. I don't know if that was good grammar, but not yet, okay? We're going to first kind of like play around the idea a little bit, and then we will get into what is actually completing the square. So I will let you know, of course, when we are actually completing the square. But for right now, I just want to kind of get us into the right mindset here about what our goal is, what we're trying to accomplish. Okay? So just follow along with me here. We're going to fill in some of these little spaces. Okay? So first of all, square numbers, right? Okay, so square numbers, how do we get square numbers? We take a number and we square it, right? So 1 is a perfect square, 2 squared, 4, right? 3 squared, 9, 4 squared, 16, and you get the idea, dot, 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 right? Okay, these are all perfect square numbers. What makes them perfect squares? You get them by multiplying a number by itself, right? So 4 is 2 times 2, 9 is 3 times 3, 16 is 4 times 4, you get the idea, okay? What's that? 5. Well, so 5 squared, 25 would be a perfect square, but not 5 itself.
You put a 6.
Yeah, if you want to.
No, it looks like 6.
Sorry, it's my handwriting. Well, and I rushed too. Okay, so I'm going to skip this next section for a little bit here. I want to jump right down to actually this section right here first, because I think this one makes more sense to do next. Okay? So let's just look at what it means to square a binomial. So take a binomial and square it. Okay? Now, one thing real quick here. Okay? I'll squeeze this in up here. X plus 1 squared does not equal x squared plus 1 squared. Okay? So in other words, you can't distribute a power over addition, right? You can distribute a coefficient. So if I put like a 2, a big 2 in front here, I could distribute that. But when you have an exponent, it does not distribute over addition like that. Okay, so that's not true. That's why I put not equal to here. So how do we simplify something like this? Well, you fall back to what the definition of something, squaring something means. What does it mean to square something? Multiply by itself. So we're going to write x plus 1, just like this. Okay, right? X minus 2 squared will be x minus 2 times x minus 2. X plus 3 squared will be x plus 3 times x plus 3. And x minus 4 will be x minus 4 times x minus 4. Okay, just like that. Okay? Now, let's simplify a few of these here. Let's see if we can see kind of like a pattern arise maybe. So x plus 1 times x plus 1, well, we got to FOIL this, right? Or you can do the distribution. So we do like x times x times 1, 1 times x, 1 times 1, like that. Okay. And so what is x times x? X squared. What's x times 1? 1x. And then we have 1 times x, another 1x, and then 1 times 1, 1. Okay. And then once we've multiplied it out, can we simplify that at all? Are there any like terms combined there? Yes. What can we combine? 1x. The 1x's. We got 2 of them, right? So we'll put those together. Yep. X squared plus 2x plus 1. Okay? And so then this, bless you, this result is a perfect square trinomial, right? Because how do we arrive at this? We multiplied something times itself. Okay? We squared a binomial and we got this. Okay, let's try the next one here. So same thing, x times minus 2, so we get x squared minus 2x, and minus 2 times x, minus 2 times minus 2, minus 2x, and then negative 2 times negative 2, positive 4. Okay, and so we'll combine like terms here, x squared minus 4x plus 4. Okay. And there is a pattern here. See if you can see. So yeah, John.
The C's of the trinomials.
Okay. Okay, the C's are perfect squares, and they're perfect squares of what numbers from the original here?
Perfect squares of the second.
Yeah, right here, right? If you square, so 1 squared is 1, and look, there it ends up, right there. What's negative 2 squared? It's 4, and look, there it ends up, right there. Okay? So you can kind of see a pattern there, a relationship. what about these middle terms here? 2x, can you see a relationship back to here? Or the negative 4x, can you see a similar relationship back to here? It's double, right. So the middle term, the b here, is double 1 and x, right? So it's 2x. And then the middle term here, negative 4x, it's double negative 2 times x, negative 2x. Okay. Let's see what happens here. So let's see here. Again, multiply it out. It's going to be x squared plus 3x plus 3x plus 9. And so we get x squared plus 6x plus 9. Still following that pattern that John pointed out, right? The 3 here, if you square it, you get that 9 right there. And then you have the x squared. Okay? And then if you do 3x and double it, you get the 6x right there. Right? And the last one here is be x squared minus 4x plus 16. And so you get x squared minus 8x plus 16. And again, square the 4. There's your positive 16. Square the x, there's your x squared, and then negative 4 times x is negative 4x, and double it, and you get that negative 8x there. Okay? So these are all perfect squares, right? These are all perfect square trinomials because they are gotten from multiplying something by itself. Okay? So let me go back up here real quick then, and let's do in general here. If we have a plus b squared, that's the same as a plus b times a plus b, and we'll FOIL it out here. So a times a squared, a times b, ab, b times a, ba, b times b, yes, b squared. Yeah, go ahead. Okay. Now I know it's harder here now because we have a's and b's, but do we have any like terms here with this? Any like terms here? Okay, so are a squared and b squared? They're both squared, but are they like? This is a squared. This is b squared. So not those. Nope. Okay, so this is a times b. This is b times a. Does that mean the same thing?
Yeah.
It does, right? Because isn't 2 times 3 the same thing as 3 times 2? Right? And so I can just as easily rewrite this ba as ab again. So this is really a squared plus, well, I have one ab plus another ab, so that's 2ab. We're adding them. So 2ab, ab plus another ab, so yeah. And then plus the b squared there. Okay? And there it is, multiplied out. Okay? And you can see exactly what I was talking about, or exactly what John was trying to point out earlier too, right? A plus b squared, look what you get. There's your a squared, there's your b squared, and then the middle term is twice a times b. Okay? Let's check this one and see if this perfect square works as well. So again, FOIL it out. A times a squared, a times minus b, minus ab, minus b times a, so minus ba, and then minus b times minus b. A negative b times a negative b will be a what? Positive b squared, right? Okay, and again, these are like terms. Yes, it's ab and this is ba, but that's okay. This is the same thing as ab, and so we're going to get a squared minus 2ab plus b squared. And there it is, multiplied out. Okay, so the square of the first term of the binomial, that's your a squared, right? And then it's twice the product of the two terms, that's your 2ab. And then the square of the second term, that's your b squared. So there are your different parts that we get there. Okay, so you just look down here, right? The square of the first term, what's x squared? It's x squared. Twice the product of the two terms, so twice x times 1 is going to be 2x. And the square of the second term, 1 squared, 1. So there's how you can do that perfect square trinomial there. Okay? Now, if we go down to this next section here, okay, you are going to create perfect square trinomials. We're going to complete the square here. So in other words, this is not a perfect square yet, right? Our perfect squares, these are perfect squares right here. Okay? X squared plus 6x plus what would make this a perfect square? Go ahead. 9. Now, why is it 9? Well, let's take a look at this here. Again, for this to be a perfect square, we need it to factor to be the same thing. Right? I need an x here, I need an x here. Okay? So again, I'm looking at this thing here. Okay, right now, without the 9, if I kind of block off the 9 there, and I just have this x squared plus 6x, okay, this factors. I could take it. It would be like an x times an x plus 6, but that's not a perfect square. I want to make this thing a perfect square. So what's it missing? Well, to factor this, I would need an x and an x to make the x squared, and then I need to come up with two numbers here. I need to come up with two numbers, okay, that are going to make 6x. Right, that middle term we add to make the middle term here. Okay? But they also need to be the same number. What two numbers add to make 6 and then the same number?
3.
It's 3. So I'll put a plus 3, plus 3. Okay? And so there it is. X times x, x squared. 3 times x, there's our 6x. And then what would I be missing? 3 times 3, 9. That's why we fill in the 9 there. Okay? Let's do the same question for this one right here. All right? X squared minus 12x. Again, if I wanted to factor it to a perfect square, I'm going to need an x here, I'll need an x here. And then these two numbers, they'll multiply to give me this. I don't know what that is yet. But they're going to add to give me what? A negative 12. And I need them to be the same. So what two numbers that are the same will add to make negative 12? A negative 6. Minus 6, minus 6. Okay? And so then what number will go here to make this a perfect square? What's missing here? A positive 36, because negative 6 times negative 6 makes positive 36. You got it. Okay? So we're taking something that was not a perfect square. We're kind of like working a step ahead and saying, okay, if it was a perfect square, I would need an x and an x. And then what numbers here? They got to make negative 12, so it's negative 6, negative 6. This is missing a 36 to be a perfect square. All right, I'm going to hold off on this one for right now. Let's jump up to this one real quick. The x squared plus 10x plus 10. Okay, same thing. We want it to factor to be a perfect square here. Okay? So again, x times x makes x squared, and then these two numbers are going to multiply to give me this, but they also have to add to give me the 10x. So yeah, what's the same number? The same number that here and here that would give to 10? It'd be 5, right? So plus 5 plus 5. Okay? And so then what's missing here? A 25, right, to make that a perfect square. Okay, perfect. All right, let's get a little bit trickier here. So let's look at this one. Okay, so again, x times x will give me the x squared. I'm looking for two numbers here, right? These two numbers are going to multiply to give me this. I don't know what that is yet. But they have to add to make what? A 1. Now, what two numbers that are the same add up to make 1?
1.
1 plus 1 is not 1. 1 half. Are you going to say, Sky? Yeah, 1 half. Ugh, fractions, Mr. Witt. We haven't seen a lot of fractions in here, but yes, it is fractions. Okay, so then what is missing right here? What's 1 half times 1 half? Or half of a half? It's a quarter, 1/4. Okay, so there are some fractions involved here. Hopefully we won't see too many of these, but yeah, there are. You guys have your graphing calculators, though, so that can help you. Okay. All right, let's try another one here. What's that? Go to the left one. So let's see here. So it'll be x, x again. And here again, we're looking for two numbers that'll multiply to make this, but they're going to add to make 3. And they need to be the same number. So what number added with itself? 1.5, yeah. Or 3 halves, if you like. 3 halves. Okay. And then to figure out this number, what do we have to do? Multiply the 1.5 times the 1.5, and it's 2.25 there. Okay. We getting the idea here? So, how are we coming up with these numbers again that I'm adding in? Okay. Well, this 3, it's half of the 6, right? 3 is half of the 6. And then to get the 9, what do you do with the 3? By itself, right? And so it's half the middle term, and then square it, and you get what you're missing right here, right? Half the middle term here is 5. Square it. 25. Half negative 12. Negative 6. Square it. Positive 36. So what's the basic rule here? The basic rule is to complete the square, okay, find half the b term and square it. Okay? 1/2 the b term and square it. That's what we're going to be doing here to complete the square. Taking something that is not a perfect square and making it a perfect square. And you might be wondering, Mr. Witt, why is that even important, to take something that's not a perfect square and make it a perfect square? Well, I'll show you here in a second. Okay, I'll show you here in a second how we're going to use this. Okay? Okay? So, turn the paper over there. Okay? We're going to use completing the square to solve quadratic equations. We're going to use completing the square to solve quadratic equations. Okay? So, let's review real quick. All right, how we solve using square roots. Okay? How we solve using square roots. All right, we're going to forget these bullet points right here. So here's an equation. You'll notice on this left-hand side we have a perfect square, don't we? K plus 2 quantity squared equals 12. What should be our first step here to solve this equation? To solve this equation here, what's our first step? What's that? Square root. Both sides. Okay? When I square root over here, what's going to be left? K plus 2 still. Because again, the square and the square root will cancel. And then over here, I'll have plus or minus the square root of 12. Okay? Right. Which, what do we do with that square root of 12? We try and simplify it, right? Is 12 a perfect square? No. But can we divide a perfect square out of it? Yes. It's going to be root 6 and 2. 6 is not a perfect square, nor is 2. Yes, it makes 12, but it's not a perfect square. 4 times what gives you 12? 3. Yeah, so it'll be root 4, root 3. Okay, so it's really plus or minus 2 square roots of 3. Okay, so we get k plus 2 equals plus or minus 2 times the square root of 3. All right, and then for our final step there, what should we do now? Solve for k. What should we do? Minus 2, minus 2. So you get k equals negative 2 plus or minus 2 times the square root of 3. And that's our answer. Two solutions, right? Negative 2 plus 2 root 3, negative 2 minus 2 root 3. Okay? Questions on number 1? It's a lot of work. Maybe. The simplification makes it a little bit trickier, sure. Okay, question, Keith? Yeah. Okay, let's take a look at another one here. All right, number 2. Question? You okay now? Okay. Let's do this one right here, okay? This one, does it factor? Yes, it does. Okay, so let me pause right quick here, okay, real quick. Because in the past, when we were trying to solve an equation like this, okay, what do we want it to equal in the past? What did we want to have our equation to be equal to over here? We want it to be equal to what number? It's a 0, right? Equal to 0. We want standard form, it's equal to 0, okay? However, the way we're going to be solving today, we don't need to be equal to 0, okay? Because if you look here, this is a perfect square, right? This is a perfect square here. We can actually factor this. It's going to be x plus 1 and x plus 1 here, which is really then x plus 1 squared equals 8. Okay? So you see here, we're not using the zero product property. We're not multiplying two things and saying they're equal to 0 and then setting each of those two things equal to 0 like we showed you yesterday, right? This one, we're going to use what at this point? What should we do to both sides here? Square root. Okay, what's the square root of something squared? Well, what's the square root of x plus 1 squared? Just x plus 1, right? Equals then plus or minus the square root of 8. Okay? And we need to simplify the square root. All right? So, Grayson, I'll get your question. Is there a question, Grayson? Yeah, okay, 1 second. Braden, root 8. What can we break up root 8 into b? Are there any perfect squares, Braden, that divide the 8?
4.
Yeah. So this is plus or minus root 4 times root 2. And what is the square root of 4, Braden?
4. Or wait, what do you mean?
What is the square root of 4? So what times what gives you 4?
2 times 2.
Yeah, so it's 2. 2 root 2 there. Okay? And so we get x plus 1 equals plus or minus 2 times the square root of 2. And then, Braden, what's our final step there to get the x by itself? What's with the x we still need to get rid of there?
Minus the 1.
Yep. Subtract 1 from both sides. Yep. Minus 1, subtract 1, that's fine. Equals negative 1 plus or minus 2 root 2 there. Okay? So you can see if we have a perfect square, like we do in number 2, like we do in number 1, if we have a perfect square on the one side of our equation, we can factor it and then use square roots to simplify, to solve. Okay? We don't have to factor and set each factor equal to 0, like the zero product property stuff. So if we can get a perfect square, then we can factor, square root both sides, and solve. And that's what our goal is for today. Okay? That's what our goal is for today. Grayson, your question, sorry.
Excuse me, got the initial equation below.
Right here?
Yeah.
Just factor it, that's all. So you have the x times the x makes the x squared. Okay, and then 1x, another 1x, that's your 2x, and then 1 times 1 will give you the 1 there. So it's just factored completely. It's like factored. That's all it is. Just factored it. Okay? So, you want to see, you agree? If you multiply this back together, you would get this, right, Grayson? X times x. There's your x squared.
I thought that was a 4 on the right.
No, that's right. That's a 1.
That would make sense.
A little bit now? Okay. Okay, we'll skip number 3. I don't think we need to see that one. I think you guys get the idea, okay? And I don't want to spend too much time on that, okay? We're also going to skip this section too because we just talked about completing the square, and I think we already have a good idea about how to do that, okay? So I want to jump right down to how we actually solve by completing the square, okay? So this is what we're going to do, okay? Now, you can run into a completing the square kind of problem kind of in 2 big ways. One, okay, you can consider this to be like one tool in your toolbox when it comes to how you might solve a quadratic equation, okay? So if you're trying to solve a quadratic equation, you can't get the factor, you can't use square roots, you're going to want to try maybe completing the square, okay? It's one of your options. Or I could ask you in the directions, solve this 5 completing the square, in which case then you have to use it, okay? So it is important that we know this method because it's going to be a way to solve some things that we otherwise wouldn't be able to solve. All right, let's take a look at number 8 here. So let's just read through what we're supposed to do here. So solving by completing the square. The first thing we're going to do is we're going to collect all the variables on the left, and we're going to move any numbers to the right. Okay, so right away this is a little bit different than when we factor, because when we factor, everything is moved over to one side and we're equal to 0, right? Like this one, we could solve this by factoring. Right? We could solve this one by factoring. We're not going to do that, though. We're going to use completing the square. We then divide all terms by a and leave as fractions, no decimals. Okay, so let's go ahead and do this right here. So we'll collect all the variables on the left. Okay, our variables are on the left, numbers on the right. So to move my numbers to the right here, what do I need to do to both sides? Add 5. Okay. Now, little tip here, leave some space because we're going to bring in another number here. Okay. We're going to complete the square. Okay. Now, the next bullet point here says divide all terms by a. What's our a in this problem? What's the number? 1. So dividing everything by 1, is it going to change this at all? Nah, so we don't have to worry about that. Forget it. Okay, for now. All right, it says complete the square on the left. Okay, and we're going to then add this number to both sides. So we're going to take this thing. Is this a perfect square?
No, not yet.
And not yet. We're going to make it a perfect square, right? So x and x. We know it's going to factor to have an x and an x to make the x squared. With these two numbers, though, these two numbers that we don't know yet, they're going to multiply to this, which we don't know yet, but they have to add to make what?
5.
No. 4, the middle term.
We can do 1 and 4, right?
But they need to be the same number. So 2 and 2. They must be 2 and 2.
You didn't say that part.
Okay, well, that's what we did before. That's why I figured you'd be okay with it, right?
And you get 6 for x.
Okay, so then what is the number that's missing here? If I have, so I've got the x times the x, there's the x squared. I got 2x and 2x, that makes the 4x. What am I missing here, though? 2 times 2, I'm missing a 4. So what I'm going to do here, I'm going to put this in a different color so it stands out. Okay, I'm going to bring in this plus 4. Now, am I allowed to, like, add some random number out of the blue to my equation? Unless I do what to the other side? Add the exact same amount. We're going to add the same thing to both sides. I got to balance it out here. Okay? So I put in this plus 4 to make this thing become a perfect square, so it factors to be this. And then I have to fix this now, so 5 plus 4 makes 9. Okay? So x plus 2 times x plus 2 is x plus 2 squared. Okay? So there we did. We completed the square. We did it. That was completing the square. And now we're going to finish solving. Okay? So we took something that was not a perfect square. We then made it a perfect square. We factored it to that perfect square that we made. And now how should we continue solving? What can we do now to both sides? Square root to get rid of the square. Okay? What's going to be left over here on the left-hand side? X plus 2. And then, well, careful, it's what's the square root of 9? 3, and it's going to be plus or minus because we're in an equation here. Okay? That was nice that it simplified. And then what do we do to both sides now? Subtract 2 from both sides. X equals negative 2 plus or minus 3. Okay? Now, negative 2 plus 3, x equals negative 2 minus 3. I'm going to actually break these up into the two answers here. Negative 2 plus 3, negative 2 minus 3. So that way I can just say it's 1 and then negative 5. So those are our two answers here. Okay? Now, did we have to use completing the square here to solve this? No. This thing factors. Okay? So the good news is, right, when I give you a random problem, you guys get to choose what strategy you use to solve a quadratic equation. You get to choose. Okay? Are you going to choose completing the square every time? Probably not, right? Factoring might be easier for you to do in this case, right? But could you use completing the square every time? Yes, completing the square will work every single time. Sometimes the numbers will be a little yucky, though, but they will work every time.
How did you get 4x plus 4 and 3 plus 4?
Right here?
Yeah.
So you're okay with what I got? How I got this? This is just adding the 5 over, right? And that's what I was left with. The thing is, this thing, it factors, but it would not factor to be a perfect square. I could take an x out of this, and I'd have x and then x plus 4, right? It's not a perfect square. I got to make it a perfect square. So I put some parentheses down here, and I said, okay, I know I need an x and an x to make x squared, right? And then the two numbers here, they're going to have to add to make this. And they have to be the same number as well if I'm making a perfect square. So what number would it be? It'd be 2, right? 2 and 2.
So when you
Right. Let's try another one here.
how you thresh
Can you hold off just so we go through this one more here, Brady, and then let you go? Is it an emergency? If you got to go, go. But if you can hold it for this one, I want you to see this one. Okay, let's try another one. Okay? Collect all the variables on the left, numbers on the right. What's got to move here? The 11. So subtract 11 from both sides.
I'm like, oh no, not today.
Leave a blank. Leave us some space, I should say. And then subtract negative 1. Whoops, sorry. Okay, there we go. Ugh. Stupid fractions. Okay. All right, again, this thing is not a perfect square. Let's see what we need to make it a perfect square here. So I need an m and an m. That'll make the m squared. I need two numbers. They'll multiply to make this one. I don't know it yet, but they're going to add to make what? They need to add to make -5. So what two numbers that are the same add to make -5? -2.5, okay, which is just half of this, right? You always are taking half the middle term here, folks. So it's me. I'm going to leave it as a fraction, -5 halves.
For you, 2.5.
I'm going to leave it as a fraction. You can do 2.5 if you want to. -2.5, -2.5. Uh-huh. Okay, and so then what is missing here? Well, it's whatever -5 halves times -5 halves is, which is 25 fourths, so 25 fourths. So we're going to add 25 fourths in here. We're going to add 25 fourths in here. Okay, again, that's additional. Okay. Yeah, so I'm going to go ahead and put these together. So -1 plus 25 fourths is going to be 21 fourths. Okay. All right, we got our perfect square there. M minus 5 halves squared equals 21 over 4. Right, and at this point we know what to do, right? What's our first step? Square root both sides. We get m minus 5 over 2 equals, and then that's the square root of, plus or minus, I should say, sorry, plus or minus the square root of 21 over 4. Okay, now believe it or not, we can actually simplify this sum here. Okay, when you take the square root of a quotient, it's the same thing as taking the square root of the top over the square root of the bottom. And that's nice because we can do the square root of 4. What is the square root of 4? It's 2, so we get root 21 over 2. Okay, root 21 over 2. And then last step, oops, sorry, I forgot the plus or minus. Last step here, what do we do to both sides? Well, we have -5 halves. We don't want to subtract it. We would add, yeah. So I'm going to run out of space here, so I'll just put it over here. So m equals positive 5 halves plus or minus the square root of 21 over 2. Okay? And yes, folks, the good news is that's as nasty as it's going to get. Okay? That is as nasty as it will be. You might have a little more simplification to do, but that's the nastiest answer you're going to get. Okay? So, yes, now you can go. Gracie?
Still, so you got, if it's half of -5 is -2.5, how did you get -5 over 2?
Because -5 over 2 is the same as -2.5. They're equal.
That looks more nasty.
Did you have to do that?
So I have to do what?
-5 over 2.
You could have made it -2.5 if you prefer, if that's your preference. But I would say that the arithmetic, when you have them written in improper form like this, is actually much easier. I know you guys think decimal is more comfortable and stuff like that, but truly, the further you go in math, it'll make life a lot easier for you if you start to use the improper fractions as opposed to the decimals.
How did you get 21 over 2?
Well, so because I had -5 halves, they multiply and give me 25 fourths. So I was missing a 25 fourths here to complete the square. So I put in a 25 fourths here, but of course I can't just add to the left-hand side, I got to add to the right-hand side as well. -1 plus 25 fourths gives you 21 fourths when you do it in your calculator. Because -1, think about it this way, -1 is -4 fourths. -1 is -4 fourths. -4 plus 25 is 21 over 4. So. Right. All right. So that's how you complete the square. Let's try maybe one or two more here, and then I will give you guys one to try on your own here. And I had my papers, and I don't know where I put them.
Is 5 and 7 homework?
So no, we're gonna skip those for now. I'm gonna come back to those. Well, no, we're just gonna skip those for now. We don't need to do those right now. Wow, where did I put them? I think I put them here. Yes, here they are. Okay. Yes, let's. This stuff is pretty complex, right? It is pretty complex. Thank you. Okay. But it's so much fun, you can even sing a song.
Oh God.
Okay, yes, exactly. Very exciting. Trey has to go next after Trey comes back and go, yes. Oh, I forgot you guys. How could I have forgotten you guys? Okay. There we go. So, if you want a way to help you remember what to do when you complete the square, there is like a song you can sing to the tune of Yankee Doodle. Okay? Do you guys know this song, Yankee Doodle?
It was a song made by the Brits to make fun of the
Can you give me a refresher?
Take the constant to the right and leave a hole behind it.
Okay.
Half the middle coefficient, square it, and then add it back to writing as a square. Now take the square root of it. Get the x all by itself and simplify the answer.
Nice.
I don't know if that really helps or not. That's like kind of.
That actually helps.
Okay.
I think my soul just died of it.
Ah, yes. Sorry, that's the other. There's one more song that'll be coming at you this unit, and that's the quadratic equation song, too. So you'll have to wait for that one. It's quadratic formula song. Thank you. Shh. Okay, so if you need a way to remember it, there it is. And if you need to hear it again, it is now on the video, so you'll be able to go back and listen to it as much as you want.
Yes.
Or as little as you want. Anyway, let's try another one here and see how we did. Okay, see how we do. Oof. Okay. All right. So number one. All right. We'll take a look here. Okay. Again, we're just following the directions that we had from before. Right. Same kind of steps here. Okay. So we're going to collect all the variables on the left, numbers on the right. So here, what do we need to move? If we want the variables on the left and the numbers on the right, what do we need to move here? The 2, right? So we'll subtract 2 from both sides. Okay, that's gone. We have x squared minus 6x equals negative 2. Okay? Again, we're going to try and figure out what number is going to go in here to complete this square. All right, if you're having trouble figuring it out, let's go ahead and factor it. Okay, we know we need 2 x's to make the x squared, right? And then these 2 numbers that are going to go here, they have to add to make what? What are these 2 numbers going to have to add to make? The negative 6, right? That middle term there, okay? So what number, or what 2 numbers can we add to make negative 6? And they have to be the same number. Negative 3 and negative 3, right? Okay, so there's that. So that means what's missing here? Well, careful, it's going to be negative 3 times negative 3, so this is going to be a positive 9, plus 9. So we're going to add 9 over here. We're going to add 9 over here, too, to balance it out. Okay, so it's kind of weird when we do completing the square, or the way that I'm showing you how to complete the square, is we're kind of doing 2 steps simultaneously. We kind of like go forward a step, and then we go back a step, and then we go back forward again. Okay, so it's a little bit weird. Negative 2 plus 9, though, simplifies to be 7. So we get x minus 3 squared equals 7. So what's that? How is it going to equal 7? You'll see. How do we solve from here, Aaron? What should we do?
I have no clue.
Yes, you do.
So lost.
Aaron, come on, bud.
So
You say that all the time. Tell me what to do here. You have an idea. Here's the x, right? What's with the x that we need to get rid of, Aaron? Okay, a minus 3. What else is with the x we need to get rid of? Square, okay? The square's on the outside, Aaron. How do you cancel out a square? What's that? Nope. What undoes a square? Anybody? Okay, square root. Yes. Okay. So Aaron, we undid the square there. We get x minus 3. Over here, we're going to have plus or minus the square root of 7. I'm running out of space. I'll have to put it up here.
I don't know, like, how'd you get the 7 in the first place?
How do I get the 7 in the first place?
Positive 9 minus negative 2.
Oh, that's
These combine together to make the 7. Okay?
shut up.
Okay? All right. And so, Aaron, you know what to do now, right? What's with the x we still need to get rid of here? He does. And negative 3, how do you get rid of the negative 3, Aaron? Yes, sir. So you get x equals 3 plus or minus the square root of 7 there. Okay, and there's our two answers. Okay? All right, we're going to do one more together. I'm going to have you guys try 2, okay? If you're already feeling good to go, you can go ahead and jump and do 3 and 4 if you want to, all right? Well, I'm going to show one more here, number 2, okay? So I'm going to assign you guys 3 and 4, all right, for you to try out here, and then I'm going to jump back here and do number 2, though, right now together with you guys, okay? So number 2, let's take a look here, okay, for those of you that want some more help, okay? Number 2, we want to, again, we're solving by completing the square. This might factor, it might, and we might be able to use factoring, but we're not going to. We're going to complete the square because that's what we're practicing right now. Okay? We're going to subtract 4. So we have x squared minus 12x. I'm going to leave some space for that missing number, and I'll put a negative 4 in there. Or, sorry, 0 minus 4 is negative 4. Okay? Again, for this to be complete, I know I got to have an x and an x. X times x makes x squared, right? I need 2 numbers then that'll multiply to make this number. I don't know what that is yet, so I'm going to forget about it. But they also have to add to make what? Negative 12. Okay? So what 2 numbers here will add to make negative 12? Negative 6 and negative 6. Okay, right? They're the same number, so we now have a perfect square, something times itself. And they're both negative 6, so that'll make the negative 12 there. Okay. If I have a negative 6 and negative 6, that means what number goes here? A 36. Well, it's positive because it's going to be negative times negative, so it's positive. So plus 36, okay, and then plus 36 here, because I got to do it to both sides. Okay, and so I'm going to simplify over here. Negative 4 plus 36 is 32. Okay, and then I get x minus 6 squared equals 32. Okay. Yes. Here. Can we finish this one real quick? I'll let you go. Okay. Sierra, what will we do for our next step here, by the way? Square root both sides. You got it. Good. Okay. That's going to be simplifying just to x minus 6. And the square root of 32, well, it's going to be plus or minus the square root of 32. Okay. And then Sierra, what will we do for our final step here? I will. I'll do that in a second, just so I can let Sierra go to the bathroom here. Well, what's still with the x there, Sierra? We got to get rid of. Yep. So it's a minus 6. So we're going to. Yep. All right, Sierra. Thank you. Yep. Yeah. Go ahead, Sierra. Okay. But Alex is right. That square root of 32, it does simplify down some. Okay. The square root of 32. I'll do that over on this side here. We should. I know. That's why I'm not going to give you like 20 of these, okay? Root 16 is 4, and then 2. So this is really 6 plus or minus 4 square root of 2. Okay? So go ahead, try 3 and 4. Okay? Try 3 and 4. And I'll come around and help you too. And 4. And if you have any questions, I'll come around and try and help, okay? If you get stuck or something like that. Yes. All right, Jackson, 1 second. Say again? I don't stop recording. It's still recording right now. Just because I don't.
How do you record? Like, where's the iPhone?
This is the camera. What you see is what gets recorded. I'm just using this as the camera. And then I have a little microphone here because I have to record the audio separately. So. Yeah. What's that? We'll get you going.
Hold on.
Yes, very good.
Don't keep going.
Yes. 25. Okay, good job, Jackson. Awesome, man.
John's probably like already somehow. Almost. See you 70.
Whoops. Yes. Yes. Who's stuck? Hey, Ron. Okay, you have gotten really far. That's awesome. Okay, so what number is missing here? Because if you multiply these back together, you'll get x times x. There's your x squared. You'll have a minus 5x and also a minus 5x there. There's your minus 10x then, right? But then you'll also have to still do the negative 5 times a negative 5. What is that going to get you? Well, yeah, positive 25, right? Because negative times negative is positive 25. You don't have that here, but you're going to add it in. So put a plus 25 there. And then you're going to do the other side too here. Okay? And so then what is negative 8 plus 25? It's going to be 17. Okay? I will, yes. And then now you have this is a perfect square. So you're going to write x minus 5 squared equals 17. Okay, and there you go. You got it. Square root both sides, solve.
That was Yankee Doodle. Yeah. Yep.
5 plus or minus root 17.
Okay.
Yes, so your minus 5 is gone. Added 5 to both sides. So that minus 5 is gone. 5. Frank, you doing okay? All right. Yes. Okay, I like that you put 25 here, but where did your 25 over here to balance it out, right? So you want to put a plus 25 there, then you'll add here with the negative 8, it'll become 17. And then go from there, okay? Yep, no, you're doing well, Trey. Just a little hiccup, that's fine. Oh, you were so close, Jeff. So close. So it's x minus 5 equals, right, the plus or minus root 17. What's with the x you need to get rid of? The minus 5, right? So you're going to add 5 over here. So the x equals 5 plus or minus root 17. Okay, you're going to add 5 to both sides. I'm going to get you that here in just a sec.
Can I just like do that one more
Say again?
The rest of the picture.
No, I'm not going to do that to you.
Do what?
Give you that much work.
How about when you don't give us
How about I just don't give you homework?
Other whole page for extra credit, front end.
Well, I'm going to give you something. All right.
Homework was virtual.
I think that's a good deal.
John, you want to? Okay. And, oh yeah, absolutely. finish that one. You got there? You're feeling okay?
Yeah.
All right.
Mr. Williams.
Yep.
Can I have one more time?
Yep.
A3, please.
Okay. All right, so let's take a look here. Let me take a look and see.
Plagiarism.
Okay.
So and I think it would act, so you did minus 3 to both sides, so actually x equals negative 3 plus or minus 5. That looks good though, Jackson, otherwise. Yeah, good job. All right, real quick here because I think people are, ready to go. Let me just show you. So there's number 3. Okay, you should have gotten x equals 5 plus or minus root 17. And then number 4, okay, let me see here. I should get, subtract the 4 over there, so we get negative 4 there. Okay. Oops. Again, this case we're going to do 3 and 3, so we're going to add a 9. Okay, so we get 5 here. So you get x plus 3 squared equals 5. And then I'll square root, x plus 3 equals plus or minus the square root of 5. Subtract the 3 over. We get x equals negative 3 plus or minus the square root of 5. Okay? And the nice thing was that 17 and that 5, you can't simplify those square roots, so you're done. Okay? Those are your 2 solutions. All right. Let me get you guys, the rest of you guys, the homework here, okay? So it's going to be 5 and 7 on this paper I'm passing out, okay? It's just 2 more problems. You have 15 minutes. You should be able to finish these up, no sweat, okay? Unless you have trouble with it, in which case I'll come around and help you guys out. 5 and 7 on this paper I'm passing out right now.
If I give you, wait, if I give you some materials in Subnautica, you.
So that one you already have done. Oh, now you want to just like leave some space for yourself.
Just square root 16.
Okay, you need that paper.
Wait, so do I still subtract the 20?
Yeah. I think this team, Aaron's already got one. Sierra's already got one. You two need one, right? 5 and 7. So I need one too, I think. And I gotta get one for Aaron.
Why are you choking yourself?
You need 1, 2, 5, 7 is what I'm gonna use. I'll figure it out. Okay. Braden. Give it a try here, folks. See if you need any help, let me know. Yes.
Wait, what numbers? I need help getting this part.
5 and 7. That's it.
I need help getting this part.
Which one? Okay. So this one, oh, what's the matter? So, right, there's nothing to move over. So, like, the first step is already done for you in this case. Let me show you guys here. I'll put it up. You see what I'm saying? The first step's already done. So, really, what it should be,
The square root of 48.
think of it this way. Like, it's already got the blank ready for you to fill in there, essentially. It's ready to go. I can, yes.
Don't try out for basketball. I will. Just for that. By accident.
Oh my gosh, I'm so nervous.
About what?
Look at my SAT.
That quick, huh?
No, I'm kind of curious what I got.
Wait, I thought you don't get your SAT score for another like few months.
That's the military test.
Is the whole page more?
Well, the ASVAB.
So you get your SAT
No, not the whole page, just 5 and 7.
That's actually only
Just 5 and
Just those
7?
two questions, yes.
On this thing?
Uh-huh. Just the two.